Hello and once again welcome to our STEAM projects. Today we are opening number 12 featuring the Raspberry Pi Pico and MicroPython. This lesson is part of our Sherpa level series designed for the somewhat experienced STEAM teacher. Today we'll expand our virtual dice game to work with multiple dice and multiple players who compete against each other. My name is Peter, I am the founder of Educomondo and a certified STEM instructor and course designer. The goal of today is to develop a game where multiple players throw virtual dice. We will ask for the players' names, keep their score during the game, and in the end we will add the total score of all players and know who is the final winner. So we will first of all work with the random function to generate a secret integer between 1 and 6. We will build dictionaries, lists and tuples to keep track of the players and their scores. We will learn about a special function called the lambda function. We will also create an interaction between the computer and the players on screen and with LEDs. And most importantly, we'll make sure that your class works as a team to find solutions, help each other and present their project in a clear way. We will use the same project as project 11, so no additional components are needed. We can use the same build. Now, because we want to add quite a number of functionality to our program, it's good to think about the structure or outline of our program and the functions that we will create. This is a great interactive moment with your students to check whether they are able to create a logical structure and start to understand the different blocks of code that will be needed. In the first part, we will create the code to switch on the LEDs connected to the Pico. Since this is a dice game, another key function will be counting how many times the dice will roll and counting the pips, the eyes of the dice. For this project, we will throw 2 dice in each round. And this is the function that will lead and will include the random number and the corresponding dictionary that maps the values to the LED patterns. The first while true function will be used to capture the number of players and create a list to store the names of those players. Within the while true function, we will create a game loop, which is also a while true loop. That game loop will continue until the players decide to stop and reply with a no when prompted to continue or not. We will end with an overview of the final score and rank the results in a descending order. Last but not least, we thank the players and express our hope to see them again, and we switch off all of the LEDs. Now, we could start from our previous program, but because this is an educational series after all, we will start from scratch and repeat what we have learned in the previous program. So let's go to our live recording. Welcome to our live recording in the Tony environment. In this project we will create a throwing game with 2 dice, multiple players. We will capture their names, their intermediate scores, and we will close the game by showing the final results ranked from highest to lowest total score. The first step is to call the modules and the classes that we will be using, and I think by now you know them pretty much by heart. So from machine import pin, from time import sleep, and from random import rand int. Next, we need to activate pins 11 to 20, to which our 9 LEDs are linked on the Raspberry Pi Pico as outputs. And of course, we let the microcontroller do all the hard work. So let's equals, and then we open the squared brackets, pin J is defined as an output, so pin out for J in range 11 to 20, 20 included, and we close with the square brackets. We also create a library to store the players and their scores, so we're going to call this player underscore scores equals, and here we use the curly brackets, open and close, because at this moment it is an empty library. The first function will control the 9 LEDs so that they will simulate the results of the dice, which we will call a pattern. So def, and we call our function turn on the LEDs, and the argument is a pattern. The pattern should be seen as a list of 9 integers that can be a 0 or a 1, and each of them represent the LED pattern to display. And we will create the library later on of those different patterns. So we use a loop function, a for loop function. So for J in range 9, because we have 9 LEDs. LEDs from the list, so square brackets, J will have the value of the pattern of J. Okay, and now we just introduce a short sleep, a short delay of maybe 1 second or 2 seconds, and we can use 1 second here. And of course, this pause can be changed as we want to either speed up or slow down the game. Okay, so that's for the first function. The second function will actually control rolling the dice. So in our case, we will be using 2 dice, and it will also return the sum. So def roll underscore dice, and here we add 2 as a argument. Sorry. And what do we want to create there in this function? Well, first of all, we need a variable to store the sum of the rolls. So the first one is the roll sum, and of course, to start with, this will be 0. Now we will start looping, looping for the specific number of dice. So twice, so every loop will now be 2 dice that will roll, and we want to generate it with each roll a random number between 1 and 6. So first, the number of rolls, so for, and we use a very neat little trick here, because a variable can also be shown as an underscore. So for underscore in the range that we have defined before, namely the number of dice, which is 2. So what do we do in this for? Well, we have a roll, a variable roll, which is a random number, a random integer between 1 and 6, because the dice has 6 die. Okay, so what do we want to do in terms of feedback? Well, we want to print this number as what is called an F string to the REPL of Thonny. Now, this is a great example of using this F string print method, which is a very concise way of printing information. So the way it works is we do print, then we say F die, curly brackets, underscore, plus 1, close the curly brackets. The roll is the roll number. So again, open the curly brackets, roll, and close it with rounded brackets. Okay, now we have created a loop to give us the roll result, but we also want to have this reflected on the LEDs of the projects. And to do this, we need to create the dictionary, as we just said, that maps the roll values to the LED patterns. So we need to define the pattern. And we will call it patterns equals, open the curly brackets, and here we will have to do some typing. So 1, and now we will add a list, so in square brackets, and we have to add here the 9 digits, which 0 or 1. Now 1 is on a dice, it will actually be the middle point. So it will be 0, 0, 0, 0, 1, 0, 0, 0, 0. Okay, so this is it, and don't forget to close with the curly bracket again. Now we need one more command, because we have to instruct the microcontroller to turn on the LEDs according to the pattern for the current roll. So, and we do that by typing turn on LEDs according to the patterns that are linked to the roll. Okay, this should do it. One last thing that we want to add here is, of course, we also want to add a sleep because we want to pause the execution again for a moment, because otherwise it will just one after the other will follow each other far too quickly. So we can add a short delay. Let's put a quarter of a second here in order to see what the effect will be. The next step that we want to do is we want to add the current roll to the total sum, because we have multiple rolls. So the roll sum is equals to, and we can make a shortcut here by just typing plus equals roll. And what this means is actually it's a shorthand for adding the value, or adding a value and assigning that new value to the old value or to the same variable. And to close, because we also want to have a result from our function, and that result of the function is the sum of all the rolls returned. So we actually say so it is return roll underscore sum, so that we know that the return, the outcome of this function is the roll sum. Now that we define those two major elements, those two major blocks, it's time to actually start working on our game itself, and we do that in a while true loop. The while true loop will manage the flow of the program. So the first thing we want to do in the flow of the program is that we want to know how many players there are going to participate. So the first thing we are going to ask, or we are going to define, is a variable number of players. So number of players is an integer that actually is going to be an input that we will ask the users, and we will ask them by prompting them, so by asking them a question, and this question will be enter the number of players. That input will be used to create a list to store the names of all the players. So we are going to have a player list with the name, so player names, and we are going to create an empty list, because at this moment we don't know, there are no players yet known, but it will be populated through the input that we will get from the different players. Again, we are going to loop as many times as defined by the integer number of players to get the names of those players. So for I in the range, and this time we don't have any fixed integer because it's a variable, and the variable is the number of players that we just defined. So for I in the range of players, what do we want to do? Well, we want to have a name, and that name is again an input that we are going to ask input, and we are going to have this again, this function enter the name of player. And here we can add actually a number, a counter, I plus 1, because we will have multiple players, and we're going to ask for player 1, player 2, player 3, player 4, and so on. In this loop, we are also going to set the initial score of the players to 0, or from the different players. So player scores, and depending on the name, we will put it to 0. Nobody will start with a head start. Now we are going to append these names, to add the names of the players to the list that we have defined, player names. So player names, player underscore names dot append with a name. So this is the code that you use to actually append, to add elements to a list. Good. I think now that we have the basic information about, on one hand, the dice, and on the other hand, the players, we will add or we will embed another while true that is actually going to manage the game loop for as long as the users choose to play, or if they don't, then they have to choose the exit. But we have to prompt each time if they want to continue to play. So first of all, we will start with number 1. So here I'm going to add it in here. So round number is 1. Because why do I do this here? Because we will be working with multiple round numbers, and each number will be added with 1 as much as the players want to continue to play, and then each time it will be round number 2, and the whole program management or the game management will run. So for round number 1, okay, so a while true, as we said, so another while true. For name, for the name in player, and the player names, so we will we loop through the names of the player names of that list. So each time there is a name, what do? We print what is happening, and what is happening. So we are going to print another F, and here we do a backslash. It is backslash new line, and we make some nice elements here. So round, open the curly brackets with the round number, closing the curly brackets, and again some nice elements here, the double stars that make it a nice layout. So we are going to print first of all what is the round number of that player, and we are also going to print F name is throwing, which will give some nice interaction on the REPL. Now we have set the number of rolls to 2, so we will get the sum as a result of the function roll underscore dice. So this is then roll equals roll underscore dice of that function that we have just created a minute ago. Now we need to update the player's score because the game unfolds with the different players, and we have to update the player's score with the sum of the rolls, and this is done by adding and replacing the variable player scores with the new total. So we just have to add here the player score, player underscore score, player scores, and of course it's related to the name of that person, name, close the brackets, and again the same trick, plus is role equals to player underscore scores. So from the name, and you update it with, you add the role and you replace it with the new variable. Now, because we want to check also the intermediate or current results in the REPL of Tony, so we are going to use another print command, another f-string print command, which will incorporate the text and the function variables in one. That's the nice thing about this, this f-string print. It's a bit a strange way, but it's a very handy way. So print, and it's an f-string, so f, and then again it's the curly brackets from the name, close the curly bracket, and so names score. And what is the name score? It is the player underscore scores from that particular player. Make sure that you don't make any mistakes in the sequence of the brackets, because it's a bit, can be a little bit tricky here. Now, because we have not predefined the number of throws, we can ask the players whether they want to continue or not. So we do that by asking them, do you want to play again or not? And we have seen this in the previous previous program, a previous game also. So I'm not going to go too much in detail, so a little bit faster. So we want to ask the user if they want to play another round. So here we are going to ask play again, because that's going to be the input. I'm going to ask again the input, so it's going to be input play another round, question mark, and then we just give them the choice yes or no. And remember that we want to use dot upper so that we eliminate any errors in our program for people who are just typing either Y in small caps or in N in small caps. So everything will be changed into uppercase. If that play again that we just received from our user, and this is here a funny thing, so if we just compare we do it the opposite way. So if play again is different from yes, then what happens? Well, then we first print a dotted line just for layout purposes. So we can do something like this, which will look nicer. And we also print, because we want to see the results, of course. Here are the results after, and then we add round number, so the number of rounds, comma, rounds. and we just do a break so that the program will stop. It will exit the game loop if the users choose not to play again. However, if if the players want to continue, so if they have typed a capital Y or a small caps Y, then we have to add a new round, because then they want to go to round number 2. And so here we have round number 1, but now they want to go to round number 2, which means that we have to add a round number. So at this level we say round underscore number, and we know it by now, plus equals 1. So we have an incremental, or we have an increment of 1, and round number is added by 1, and it is the new round number, which is going to be 2, will be the new variable. Okay, and then the loop starts again. Excuse me. The loop starts again until the players decide now it's been enough, we want to stop. Now, if they want to stop, what do we want to do? Well, we want to create a nice overview, and we want to add all of the subtotals that we have seen so far. So the next step is to show the final results, and we want to print this and we want to present this in a nice tabulated format. So the way to do that is, because we're going out of this while true loop, so we're going to print what are the final scores. So print, open the brackets, with the new final scores, nice overview, and we also add a line in between, so very simple, just like this. So what do we want to print? So we want to print the total scores, but we also want to sort them from high to low. So we have to sort the scores first by creating a new variable using the sorted function. So sorted scores, which is going to be our new variable, is the function scored. Sorry, it's not scored, but sorted. Sorted the player underscore scores items, the items from that area. And here we are going to use something which is called the key is lambda x squared brackets 1. And I will explain this in a minute. Reverse is true. Okay, what does this mean? Well, this line sorts the items in the player scores dictionary and assigns the results to the variable sorted scores. The lambda version, or the lambda function, is a very concise, it's also called a throwaway function, but it is a very concise way to define an anonymous function that takes one argument x, which represents a tuple from the list created earlier. This function returns the second element of the tuple, which is x1. And x1 is the player's score. So the sorting will happen based on the score in each tuple. Now, I use the word tuple, and we haven't really talked about this a lot, but you will hear this a lot in Python programming. A tuple is an ordered collection of items that you cannot change. So very much it's a kind of a list, a very special list, but you cannot change anything in that list. So it is very important for applications where data integrity is very much important. For instance, like scores in games. Next, we use the rank function to unpack each tuple into 3 variables. And it's going to be the ranking, the name of the player, and the score of that player. So, for rank, and in between brackets we are going to type name and score, and then in enumerate, sorry, not enumerated, but in enumerate from the sorted scores, and we end with 1. So it's a loop, so we have our double point. So enumerate will add a counter or an index to each item in the list starting from 1, and that is why you have to add 1 here, because by default this is 0. And now we are ready to print everything. So print F, and what do we want to print? We want to print the rank of the name and the score, and the score has to be, of course, in between curly brackets. And we can again print some dotted lines or some stars or whatever you want to kind of make the layout a little bit nicer. To close the game in an elegant way, we of course have to ask once more whether the players are absolutely sure that they want to stop. So once again, we are going to ask the user, do you want to play a new game? So once again, play again, our variable play again, which is going to be the input that we will get from our users. So we're going to have new line, play a new game, question mark, and again yes, no. That's the input that we expect from them. And of course again in upper, and if that play again is different from yes, exclamation mark, I've lost my exclamation mark, here it is, exclamation mark, yes, what will happen then? Then we will print a nice thank you. Thank you. And of course we hope to see the player again. Wishing them have a nice day. Wishing them a nice day. Exclamation mark. and we break. This is exiting the outer loop. Now, one thing that you can add is at the very end, you can also make sure that all the LEDs are off because sometimes some LEDs may continue to be lit. So it's not a bad practice to ensure that all LEDs are turned off. So what we can say, so for LED in LEDs, and we just type here that the LED value is set at 0. That's it. So quite some programming. Let's see if it works. Hopefully, and otherwise we will have to do some logical fault finding. Line 13. Line 13. What is wrong in line 13? This is not just 2, but we have to have number of dice is 2. So we have to do that. Oh, and we start with our game. So that was the only error that we had. So let's give it a try. We are just going to play with 2 players. And player number 1, let's call player number 1 John, and let's play number 2 is Mary. Round 1, and oh, we see that there is something wrong again. Trace back in line 45 in module. Function takes 1 position argument, the 2 were given. So let's have a look at line 45, line 28, maybe it's somewhere here. Ah, here it is. This is already. Of course, it has to be a point. Okay, let's run again. Number of players, 2. We said it was John and Mary. Die 1, round Mary 2. And yes, we say, yeah, we want to play another game. So 5, 3. And as you can see, it actually is mimicking the same on our breadboard here. Now we're going to play, yeah, why not? So we can see we have nice. So 3 and 1, 6 and 5, and all our LEDs are doing what they are supposed to do. Now we said 3 games or 3 throws is enough. So let's do N. No, and Mary has 1 with 26 and John has a total of 16. And again, as you can see, we play or we ask for another play. We say yes or no. If we put yes, it will start again. If we say no, it says thank you and hope to see you again. Have a nice day. Let's go back to our course and wrap this particular lesson up. Now, the one thing that is not working, and I think it is because we need to put it in here, is that the LEDs are still on. So let's run it again. And we do it again with, just to see if it works. 1 player, and the player is John. 5 and 3. We say no. Do you want to play again? No. And now you can see that the LEDs are also going off. So again, the indenting is very important for MicroPython and Python. It did not create an error message anywhere, but as you have seen, it did not switch off all of the LEDs. So the last score remained as an LED display. And of course, we didn't want that to happen. So we fixed that also at the end. And now we can go back to our lesson and wrap up our lesson. I hope this also works for you. If not, well, you know it and your students know it by now also. Then this is no time to panic, but to conduct some critical review of the code and checking both error messages and the physical project. Now, let us segue for a moment and see how artificial intelligence can help us to improve our own lessons. And I'm taking the example of a function that we have introduced in our lesson, the lambda function. So let us take a look at how we can actually use artificial intelligence in order to explain what the lambda function is. So I'm going to Gemini and just typing in explaining what the lambda function is in MicroPython and explain it at the level of a 12-year-old student. And as you can see, immediately we get quite a nice overview and inspiration on how to explain it to your student. And this will help you a lot in order to prepare your lessons, to make certain things more visible for your students, and so on. And there is absolutely nothing wrong in using generative AI, the tools that we have, in order to make your lessons better. So I invite you to experiment with this. Before we wrap up this lesson, I want to share again that there is a nice bonus in case you want to include a 3D printing project in your STEAM projects. Follow the Tinkercad link in the description to print an LED holder in the shape of a die. And that's it for lesson number 12. I am confident that you and your class enjoyed it. Now we're ready for lesson number 13, in which I want you to buckle up because we are going to create a reaction game. Looking forward to see you again. Bye bye for now.